evening. A very warm welcome to everyone joining us today. After the successful conclusion of the first day of our faculty development program, which witnessed enriching inaugural sessions and thought provoking lectures, we now gather again for the second day with the renewed enthusiasm and curiosity. Day 1 led a strong foundation with inspiring addresses by our dignitaries and expert talks on sustainability in wind power and urban sustainability. Today, we'll continue this journey of learning with another series of insightful sessions from distinguished speakers who will share their knowledge, experiences on contemporary issues and innovations in engineering and sustainability. Let us now begin the proceeding of the second day of our FDP. Moving into our third session, it is our great honor to welcome Professor Sudipta Day, Professor at Department of Mechanical Engineering, Jadavpur University. Professor Day is a renowned academician and researcher in the field of clean and sustainable energy. He completed his BE from Bengal Engineering College, followed by MTech and PhD from IIT Kharagpur. His global academic journal includes research stints at Sweden and the KTH Royal Institute of Technology, Stockholm. He has also represented India in several prestigious international programs, including collaborations with the Technical University of Munich and the University of Bologna. Professor Day's contribution spans across clean energy, hybrid energy systems, and sustainable technologies with over 150 international publications, multiple books, and widely used McGraw-Hill textbook on power plant engineering. He serves on editorial boards of leading international journals and has been recognized with the INSA Teacher Award, the Shiksha Ratna Award by the Government of West Bengal in the year 2022. And he has also received several fellowships for his outstanding contributions to education and research. Today, he'll be sharing his insights on decision making for sustainable decentralized hybrid energy system, a topic of immense relevance in the transition towards greener and more resilient energy solutions. Sir, kindly start the session.
हेलो
Yes, sir.
हेलो
Yes, sir. You're audible.
Yes, sir.
Ah, is the screen still not visible? No? ও মিটিং থেকে লেফট হয়ে গেছি দাঁড়াও, তাহলে আবার জয়েন করতে হবে।
হ্যালো,
হুম, হুম।
sir, you are visible now.
Huh?
Video is coming, sir. Share the screen.
Video
Hello?
is coming, but I'm
Your
trying
video
to.
is coming, sir.
Yeah, I'm trying to do that actually. Anyway, so these things happen sometimes. Let me check. Yeah, share. Entire screen. Huh. Is the screen now visible? I mean the PPT? No,
Yes, sir.
visible, no?
No, sir, we can't able to see, sir.
The screen is not visible still. I mean,
Not
PPT
visible.
is not visible.
No, not.
Hmm.
PPT is not coming.
Then I should leave the meeting and then join again. Sorry.
मीटिंग को म्यूट करना है क्या फिर भी भाई
Sometimes it happens.
सब लोग ऑफ से
Participant, please mute.
ಎಲ್ಲ ಎರಡೆಲ್ಲ ಹಾಕೊಳ್ಳಿ ನಮ್ಮ ಮನೆಗೆ ಅವ್ನು ನಿಗಮ. Kindly participant, please mute your audio as well as switch off your video.
The screen is visible now.
Yes, ma'am.
Is the PPT visible?
Yes, sir. The
So I can
screen is-
start?
Yes, sir.
Okay, everything okay, fine. Sorry. So maybe in the meantime, some more people have joined. That may be my trick. Anyway, so what I'm going to do today in a 1.5 hour, it's impossible to teach you some very big research topic. So what I will try to do, the sustainability or sustainable development is a word now, which is not only a catchword, but a cash word. Because whenever you write a project or a proposal, if the sustainability is there, we get it easily. So my idea will be to transfer that idea of sustainable development itself and how it can be extended to distributed energy systems analysis. So as here is mostly faculty members, some research scholars maybe as I expect, it will be their orientation. I assume in general, the participants are research oriented so that they want to make something new not that it's a classroom lecture. So what I will try to do, I will try to give some research clues where you can get, how to get your good research publications in high impact factor journal in this particular field of sustainable decentralized hybrid energy systems. And there, in my perception, the sustainable development, everybody has got their own way of looking into it. And honestly speaking, none of them are fully correct, including myself. So I want to put that problem in such a way so that you can start thinking, what can be your approach? One thing is very sure, sustainable development is such a big concept or rather vast idea that the approaching towards sustainability is our target, not to achieve sustainability. So I will discuss the issue from that perspective. What can be the research? One of the research approach towards this direction, obviously in a very narrow domain of distributed hybrid renewable systems. And also to give the idea or take the feedback, because this is the faculty development means it should not be one way. We can have a discussion, good discussion, interactions, I hope, after the presentation. So I guess my screen is also visible and I'm also audible. Just give anyone feedback, then I'll go to the next slide.
All are right.
Good. Now, what do you wear? This is the evening drawing room of our previous forefathers. So they were all enjoying with some fire. Children are there, the family is there. And this is the modern drawing room in the evening. Undoubtedly, there is a gross difference. And if you look into the modern drawing room, most of the, or almost all the activities are technology driven. And the major factor in all this issue is one form of energy, that's the electricity. So now our modern civilization apparently looks to be much more developed. We cannot deny. That's called the living standard. Earlier one, maybe they were peaceful or less peaceful, but living standard was currently is better. But there is a question. Are you confident that it is really a development? There lies the starting point of the entire sustainable development concept. Now, let me see just two figures. The question is, the top one, all of you can easily identify. It's a power plant, thermal power plant, coal-based power plant, mostly I can say. And the bottom one is a picture at maybe at North Pole, where it should have been only ice. And this unfortunate animal, polar bear, they can only survive on ice. So he is trying to live with only the rest piece that is remaining. Maybe a future picture, but this is actually a picture given to show the crisis. And all of you being at that level of advanced knowledge and research, because all of you are teachers or other research scholars, you can correlate between these two. So the greenhouse gas emission, mostly carbon dioxide emissions from the power sector. Obviously, this is not the sole source. There are many sources of this CO2 emission. They make this situation. And the question comes whether, this is an acceptable development of civilization or not. Interesting part is, in global warming, source is local, effect is global. So wherever from this greenhouse gas gets emitted, India, Bangladesh, maybe Canada, USA, effect is same. So it's not a problem that can be addressed by a single country. It has to be a global change problem. And that's why in Jadavpur University, we work in a particular research center. I also belong to that center, what is named as Global Change Program. Sustainable development, climate change, these are all global change problems. Now, do we need to decide the actual need and the excess, which can be alternately called as greed? In fact, sustainable development definition, I'm coming to that point, which is formally defined. If we look into our Indian philosophy, it's not a new concept. United Nations rather took it later. It started much earlier, and that I will try to correlate. So, whether you have properly identified your need or you are driven by your greed, That makes the difference in the sustainable development approach. But how to guide people for it globally with wide variations of geographical, economic, social constraints? Here, we belong to a specific ethnic group, South Asian ethnic group. But obviously, if it is a global problem, there are different ethnic groups with different crises or challenges, socioeconomic conditions, geographical constraints. So, if you want to lead those people towards a common goal, it's impossible to have without any very clearly defined guidelines. And obviously, with very clearly defined guidelines also, you cannot reach that unless there is a structured program to move towards that direction. In fact, that's why there are certain things defined which already yesterday some of the speakers has mentioned. So I would like to please mute yourself, otherwise it's become very much disturbing. Or everybody mute. Okay. So now we are looking into a bit of background, how this sustainable development issue comes. This sustainable development concept originally started with an United Nations Commission, which is called Brundtland Commission. The name came after the chairman of that particular commission. She is a lady, former Prime Minister of Norway. Her name was Gro Harlem Brundtland. She is not only the Prime Minister of Norway, but was an environment activist. Unfortunately, I had some collaborations with Norway and several visits to that country. That does not only look like a very picturesque country. Everywhere you will have a different feeling how much naturally careful they are towards the environment. It's a culture. But the question comes up, can the same culture be incorporated into a country like India, where we don't have regular food for everybody? So sometimes good things inspire us, but to achieve that good thing, we need to make our plan, we need to develop. So interestingly, Norway being one of the richest country in the world, they are leading that concept. They are telling, no, we are not still developed. We need some further development to make it a global development, which is called sustainable development. In the Brundtland report in 1987, there was a definition of our common future. This common doesn't mean common within the boundary, political boundary, or within some continental boundary. This common is the global common. So the Brundtland report, which has mentioned this particular term, sustainable development. And then in 1988, there was a Center for Our Common Future replaced that particular commission. Incidentally, I have seen it also. Interestingly, from there, that concept has been propagated that we have to move towards a direction globally, not as a single country. Now, there comes the final statement of the sustainable development, the formal statement, better to say. This is already mentioned. It is the development that meets the need of the present without compromising the ability of future generation to meet their own needs. Now, interestingly, this is philosophically a very nice statement. Everybody will agree. What is the problem? If we can live well and the others also we can allow to live well, the problem is something different. Here the issue comes, how to do it. Conceptually, this is good, but actually how to implement that, that's the big question. And in fact, I will raise that question throughout my presentation. Now, unfortunately, some screens are there, right? Anyway. Yeah. Now the sustainable development, when you look into a particular problem, then I always say, you better break it into some small sub-problems so that your solution can become easier and some section of people can take care of some part of that problem. Towards that directions, the 17 Sustainable Development Goals have been declared, discussed at length, so I will not spend much of time, but only I will have some brief comment on that. This out of this 17 sustainable development goal, which has been discussed already in the last class by two speakers, both speakers. Interestingly, if you look into these, some of them are overlapping or redundant. Say if we consider the goal number 2, zero hunger, and the goal number 1, no poverty, do you think hunger can generate out of wealth or out of prosperity? The people go in hunger if because they are only poor. So we can never say that these goals are not interdependent. And similarly, some of the aspects will become mutually, some of the goals of this particular sustainable development, if you look very precisely, they may be conflicting also. That's interesting. See, if we take about the, say the issue of the climate action, and if you take the actions, I mean the sustainable development goal 1, no poverty, interestingly, the climate actions need money. And that's why there is a lot of initiative at the political level globally. Somehow there must be some provisions which you call what you call climate fund. But to make that provision, there is a political, I mean, diplomacy conflict, whether that money should be provided only by the rich countries or the poor countries should also share. Interestingly, the Sustainable Development Goal 1 and 13, they are partially conflicting in a sense. People are not completely converging. The poor or underdeveloped countries have the reason you have made this particular issue of the climate change because you are industrially developed, released more carbon dioxide. So now you have to take the responsibility of your forefathers. But on the other hand, if it is not equitably distributed, the responsibility, at least with a certain share, the advanced countries are also telling it cannot be a responsibility of only few countries. So it's becoming contradictory. But whenever you start to solve a big problem, especially the global problem, you have to be very cautious. At starting, you must have certain problems which may not be solvable right at that moment. You have to proceed and then find out new problems. Slowly, these issues will converge. So, still, the entire world accepts that this 17 sustainable development goal has to follow. And then the world also accepts, I mean, the different countries have also accepted this particular goal. Every year, they have to submit a report on the performance on the basis of each of these goals, whether these are making proper justification for towards the sustainable development or not. That will be counted or rather evaluated much later, because whatever the actions we're taking, that should give that particular effect, not in a very short span, but over a longer time span. Now, what is this? This is maybe they all are blind people. They cannot see anything. They are trying to feel how an elephant look like. And whenever there is a blind person try to feel the elephant, it's so big. Wherever they touch, they feel that's the shape of this particular, oh, I'm very sorry. That's the shape of that particular animal. But it's not that true. Whoever just touching the trunk, he is thinking this particular animal is, why it is happening? Anyway, this particular animal looks like a so-called cylindrical. Somebody feels it's a surface-like thing. In fact, looking into the sustainable development is also something like filling by the blind people of a big elephant. I'm telling it including myself. Maybe I could not have understand the whole concept trying to do that. So many men, many ideas, or many perception. The people from economics, the economists, they just try to find out wherever it is economic or not. So whenever you listen to an economic person from the economics, you will feel, okay, sustainable development means everything has to be very economic. When you meet an ecologist, his or her perception is give the highest priority to the environment. Nothing else is there. So where from that particular fund will be arranged, he or she is not responsible. They have to think that only ecology is the objective of the sustainable development. Physicists, as they always go for making their own way of thinking in the path of entropy or negentropy, maybe they are trying to interpret it that way. The chemist or the engineer, they have got their own approach of material design, reuse, recycle, and waste management concept because they can do that only. They do not have the perceptions of the social aspect, not much. Most of the engineers are lacking, but currently it has to be. And the social scientist, they have got a different perception of this compatibility of the human society, and matching between these two will be the goal. Now I'm putting a question to everybody. There is apparently it looks like a boyfriend is there at the center and some of the girlfriends are fighting over a single boyfriend. Apparently it looks like that. But my question is, who is he and who are they? Interestingly, this is the sustainability, and these are the sustainability factors. Means it's a multi-factor issue. So always sustainability itself has to be push and pull situation. Some of the factors are trying to pull it towards their own bias, and the other is trying to do it in their own bias. So always these two clashes creates a big problem for the overall sustainability to achieve. And this is the main climax of the sustainability, specifically when you want to make a research also. Because in research, in general speech, many people say this is sustainable manufacturing, sustainable transportation, sustainable blah, blah, blah. But which one is actually sustainable for a given system? Say I have given an option of 4, 5, 6 things. Can I make a compare which one is more sustainable? That's the big challenge for policy making as well as for the research. And I will try to address that issue in my presentation because here the research approach of assessment of sustainability is a big issue. And we have also made our own framework, sharing with you and getting your feedback. Now, can you adopt a simpler methodology to address it? This has also been discussed in last class. In fact, the moving with 17 goals simultaneously and making the correlations between these 17, which are widely varying different characteristics, it's very difficult. So to make it simpler, to assessment of sustainability or sustainable development pathway, we have to make it simpler. And then from that, this has come up, already discussed, 3 basic pillars: social, economic, environmental. But what has not been most probably discussed in last 2 classes, there are some partial sustainability issues. Say, economically feasible, socially accepted. Example, obviously, the greatest example may be the mobile phone. All of us are accepting that practice or you are using the mobile phone because this is available for a very cheap price to a very high price. But undoubtedly, you know that the electronic waste is becoming a future threat for sustainability itself. So it doesn't contain the environment component. So what is happening then? Unfortunately, the partial sustainability sometimes create even greater problem than full sustainability. Than the less sustainability condition. Another example of this socially accepted and economically feasible solution, which is the greatest challenge with respect to environmental, I should not call it greatest, one of the big challenges of the world is the plastic pollution. Because why the people are not leaving plastic? They are making a lot of programs for plastic removal, no plastic, etc., etc. But anyway, people just go on listening and then come back with a plastic bag for their market, from their market goods. So this thing is because it is economically very cheap, possible to afford, and socially people have become convenient with that. But plastics in the form of microplastics has now become a global threat. Some people have got their approach not to think of these 3 pillars as separate. They think that they rather propose or think that this is a hierarchical three pillars. Hierarchical means one having importance above the another. According to their theory or perception, as I have told you, the sustainable development concept is not like Newton's laws or thermodynamic laws, because these are defined laws. Here, still, there is no specific, very rigid framework still accepted. Very flexible options are there. Only one statement of United Nations, that's the only existing, that fulfill your need and let the future generations to have their provisions to live. So that's a philosophical statement. Action plans are very difficult to decide. So in the hierarchical plan, the economy is undoubtedly at the core of the things, but society is bigger than that in the hierarchy. Without societal acceptance, any economic thing is also not acceptable. And environment must be on top of everybody. Because in that hierarchy, if your environment is gone, then society existence will not be there. And if the society doesn't exist, the question of economy doesn't come at all. But the three are also interacting with each other. So whether you accept they are three different pillars, or you accept there is a hierarchy, that's your choice. Because this is the two different ideas promoted in the campaign or the so-called research market. But undoubtedly, we must admit that these are the three basic pillars. Rather than going into 17, we will try to follow these three basic pillars to fulfill as much as possible. But now question is, whenever there is a single parameter to maximize or minimize, mathematical equations are very easy. Differentiate, put it 0. You can get that value, corresponding to which it will become the maximum or minimum. Unfortunately, if it is a multi-criteria, then you cannot simultaneously maximize all the three criteria. You have to optimize. So maximizing and optimizing are different problems. And here, in the framework of the research, we will see how this makes a very interesting challenge and how the mathematical framework has to be made. Because being a scientist or engineer, we cannot leave it to the subjectivity of individual perception. No, I think this is good, sustainable. No, you have to make it a very rigorous framework so that you can tell out of these options, this is really sustainable, this is more sustainable, this is less sustainable. Not anything is full sustainable. We will see that in further discussion. Do you believe in God? Somebody may tell it, why you are asking these things? That's my personal choice. Yes, keep it within yourself. I'm not asking, I'm just telling. Then the question is, the problem arises how to attain the God. Whether you believe in God, if you believe in God, that's the first question to ask, this more important question, how to attain the God. Here there is a large fluctuations or other variations from person to person. Some feeling going to temple every day, maybe a particular time, even precise, can be a way of attaining God. Somebody may feel, no, doing good service to the poor people or other needy people, I can serve the God. So the question is, to believe in God or achieve in God, they are not the same thing. And now, different people have different methodology to attain the God, sustainability too. This is my 100% conviction after doing some few research in this particular field. That means concept of sustainable development is rather understandable by everybody, but how to achieve it, still it has not emerged. So different people have different perception. Whoever is working in the urban sustainability, they have got their own way of thinking sustainability. I'm not telling according to their convenience, their best possible belief. Similarly, who is thinking about the rural sustainability, they have their own perception, how it can be met. Who is thinking about transportation sustainability, they are also confined within that particular area only. But whether the transportation sustainability has got certain adverse effect on the urban sustainability or rural sustainability, that's most of the people are not thinking. So making a comprehensive policy, easy to say, but it's not very easy to actually decide and implement. So my suggestion is, being from the research community, please concentrate how these conflicting factors can be brought into a uniform framework structure so that we can have a pathway properly not achieving fully, but moving in a path towards that direction. Is there any accepted global standard for sustainability assessment? This is a question I'm putting to myself. If it is there, no problem. Because, say, visa, that means going from one country to another, there is a standard acceptable protocol. There is a diplomatic mission people. They will evaluate, and depending on the foreign policy, they will either allow or not. So, done. Nothing more research is there. Only time to time, you can make some. Your principles will vary little bit. Some of the countries may be enlisted, visa will not be allowed to those, may be allowed easily, may be allowed not that easily. Some may not need visa earlier. They can enter into the country and then get it. But for sustainability assessment, honestly speaking, there is no such global standard yet. I'm considering all the countries, they all are trying to do that. Unfortunately not. So whenever there is a knowledge gap, if it is available, there is nothing to do. Because in a research world, we tell something the problem. In life, problem is a difficulty. In research world, no problem is a difficulty. Because unless there is a problem, we cannot just do research. So if problem exists, then the researchers also exist. So interestingly, whenever there is a knowledge gap, there exists a research opportunity. And converting challenge or hurdles to opportunity is the real good orientation or objective of the good researchers. So we are trying to develop that framework. We means all, but our research group is also towards that direction. If you feel like after this course is over, then you can also join that group to find out your contribution towards this direction. All research are not necessarily immediately give the good benefit, but following that path is the throughout our life objective. To some extent, we can contribute to that field. This field is absolutely open for the research scholars to contribute. Now I'm coming into the process economics part. Why I'm started discussing? I've already discussed, rather, you all know that out of the three pillars, if anything is not economic, or rather the best possible economic solution, then it can never be sustainable. So from that perspective, the process economics is very important to understand. Now, what happens in a industrial production process? I'm just taking up industrial because we are all engineers, or rather, at least from the science background, I assume. There can be social science people also, but in a mass production, this process is most important, process of economics. And there are different costs involved in a particular product or service. What will be the final cost? And in that case, you have to find out that break even. Break even means, obviously, to what extent you can produce that particular product. If you cross beyond that, your profit will not be maximized, and you have to compromise at that level of production. And amount of, the capacity or size of that production in industrial system is a very critical issue, because unless for a very carefully designed plant capacity, you cannot have the minimum cost of production, both on the lower side, on the higher side, the cost of production will increase. So determining the break-even point, both with respect to production capacity and the plant capacity, are important to be economic. In any sustainable planning, you must have to be cautious. We should not miss this particular point. We have to choose this very properly so that we are not losing the best possible economic option. Now, there are the different possible options in engineering or management that we can assess the cost, and cost assessment is also not very easy in a sense. Always remember that there are two different things, cost and price. Not necessarily they will always go hand in hand. Because, for example, what can I say? vegetables, who are rather the poor people who are selling the farmers, they are selling their vegetables at the market with a very marginal profit, because whatever is the price they get it and their production cost, they are almost close. That's why they are poor. But the person who has got a petrol pump, or on the other hand, a liquor shop, they are making much more profit than selling unit things. So the price and the cost, these two are not directly always one is to one correspondence. But the capital cost estimation for a large production system, because we the engineers, the price will add up not only the revenue or the profit, but also the government taxes and duties that also add up to that. Because all of us are aware that two main transportation fuel, petrol and diesel, are yet to come under GST. And that's a big, sometimes the people go on, debating over that. And why not? Because whatever is the actual cost of petrol and diesel production, the market price of those fuels are much higher, because state and central have their own taxes put on that, and they can adjust that for their revenue earning. And interestingly, there it happens that all states doesn't have same taxes, and so whenever there is a increase of price of those items, they are also blaming each other. Why I'm mentioning these things? Not to create any political controversy, but to say these are issues related to social sustainability. Because unless you have a very unified mission from all the sectors, you just can't reach the sustainable development path. Anyway, coming back to the engineering and management scientific principles, the capital cost estimation can be fixed capital investment, working capital investment. Then the capacity ratio means if you want to escalate, that's we call the scaling effect, to increase your capacity even more, then obviously not necessarily they will increase linearly. There will be a exponential, the power x, maybe one, maybe something else. And then updates using the cost indices. It can be, you have to consider the depreciation issue, the declining balance method, and modified accelerated cost recovery systems. So depending on all these issues, the economic aspects of the industrial production, this is very preliminary idea. Don't think this is the exhaustive. But in starting research of techno-economic analysis, at least you have to be aware of these issues. Then obviously, much more complicated things will come. Time value of money and other things will come into picture. And without time value of money, you can have the return of investment. The straightforward estimation is how much your investment you have made and how much annual profit you are getting it. And if the return of investment at least not higher than the bank interest rate, the people who have money, they will never go for the investment, because they can put it into the bank and get the interest out of that. That has to be more than the bank interest at least. And that's why, the Reserve Bank has to control that particular bank interest rate to bring the money more to the invested in the industry sector in the form of share purchase and other things. Otherwise, what will happen? The money will just remain non-productive, and the bank cannot give the interest unless it can also earn from the market. And that's a economic balance. And think of if you want to do your research in your domain only as an engineer or scientist, you need not to know all these things. But if you want to do research in sustainability or sustainable development, never think you can ignore this basic principles of economics or basic theories of economics. You have to. With time value of money, we can the payback period. That means that is another alternative concept. We can invest and then calculate how many years investment means. The concept is very straightforward. You are initially putting money from your own pocket. Then you are getting profit out of that. But that profit will not be instantaneously. That will take a time zone, or rather over a certain period of time, you can get those return. And that's the actual happens in mutual fund, share fund, share purchasing everywhere. So how many months or how many years will be the, just for a minute. Hello? না 1 মিনিট, আমি এখন একটা প্রোগ্রামে আছি, একটা লেকচার দিচ্ছি, একটু পরে। হ্যাঁ, আচ্ছা। So whatever will be the, time when we will get back that particular return, that's a time, that's called the payback period. Sometimes it looks to be lucrative. Shorter payback period is very good. If you are a mutual fund holder or the so-called shareholder, it's good. You are putting money, getting money. But if you are an industrialist, never think that shorter payback period will give you the greatest advantage. Generally, what happens? Cheaper items seems lucrative, but their lifespan is shorter. So if your payback is shorter period and if your equipment doesn't have the life even up to the payback period, then what do you expect? You can expect that your return of that invested money will not get. So there is certain logical decision the industry people have to take. What should be the minimum payback period? That depends on the expected lifespan of that particular plant or equipment. I'm not going much more detail, but in our research, we have to consider or distinctly show all these issues in the economic sustainability. Never think quick return of money will make you sustainable. You have to be patient for a long-term gain. Just the same principle of the mutual fund and share. Now I'm coming into another very important aspect of so-called life cycle assessment. The meaning of this term from the 3 words itself, life cycle means it's a cycle of what? Life. And assessment means that particular cycle assessment. In fact, how it originated is something like this. Initially, people were telling that it is polluting. It is damaging the environment. But the question is, how much quantification you could make? And more important problem is, generally the pollution we correlate with human health or some other animal's health or creature's health, mostly human health. Now the question is, for a machine that has a definite rule and that governing rule will control whatever is the output for a given input. Human or living creatures, there is no such single 1:1 rule. It becomes validated with respect to large statistics validation, so that getting exposed to the same pollution, whether one person will acquire cancer and another person not, smoking over the more than 50-60 years substantially, some people are fortunate not to have the cancer even after that, but that doesn't justify you should smoke, because medically it has been proved that that causes cancer. So the main problem of the life cycle assessment came into from that particular direction, that which particular issues to be looked up for a environmental impact assessment. And if it is not uniform throughout the world, then the problem arises something different. What is that problem? Since I'll say it is good, how much good? 40% good. Somebody will say, no, it's 50% good. So we cannot just leave that particular assessment to everybody that they can make their own judgment. It should be an international standard protocol, though honestly speaking, the life cycle assessment doesn't give you exactly absolute environmental impact. At least my research from, those who do research in this particular field, they know it. It's a framework, rule, that you do the life cycle assessment, get certain numbers on some of the impacts. You just be happy with that number, that if somebody does the life cycle assessment, they will get that number and they will compare with the results. But that doesn't mean actual environmental impact will always follow the life cycle assessment principle. Now, just 1 minute. Yeah. Why the life cycle assessment at all came into picture? In nature, if you look into the natural process, we call the nature-based solution, that's a very common term. Generally, what happens, there is a production method, and in production means in life, living creatures, sunlight has a big impact. And then the consumption means consumption, we can put it in that way. During their lifespan, they are doing it. We, the human beings, are cremated according to our religion rituals. But the normal animals or creatures, they get just lost. Lost means not in that sense lost, but getting decomposed in the nature. So then again, the new life starts, and those decomposition contributes to the new life also. So it's a process cyclic. And from the engineering or science background, we know that process can only exist for indefinite period if it is a cyclic one, because cycle goes on moving time and again, because after finishing up the end, I mean, coming back to the initial state point, then it comes back to again through the cycle. So nature is cyclic because it is eternal. But what happened to the so-called civilization? It's a non-cyclic or linear process. We are extracting the limited reserves, natural resources, and then making, in the name of production, we are delivering something. And once our purpose is solved, we are throwing it as a waste. And that's why any population, wherever it may be, even going to the Arctic pole, there will be a waste created. And that waste, unless you manage it properly, that's basically the end point of the consumption of that particular civilization. I mean, consumption of the human being out of that civilized life. So being linear, the waste generation, it's a very common observation that continuously generating waste means we are destroying ourselves in a sense. Then sometimes waste will be heaped up and we cannot just come out of it. And in any big city, management of waste is a very big problem. That harms the sustainability. So this is the effect. That means in the name of civilization, we are affecting our environmental components. Now, what is the origin of LCA or life cycle assessment comes from this particular aspect. We are taking care of the resource scarcity, environmental pollution, and need for renewable energies have been the center of interest for the few decades. Resource scarcity, that's also a consciousness, and the perspective of resource scarcity is changing very fast. Why? Have you ever thought of continuously, do you pay any tax for the oxygen available in the air? We get it now, so we don't realize it. But if someday, how much oxygen, maybe some meters will be put into our nose, and how much oxygen we take, we have to pay money for that. We don't think it. Initially or earlier, we thought that our drinking water should be free. Yes, it should be, I believe. But now you know the wastage of those treated water has put the many of the big cities, there will be water meter. So think of, don't take it to be granted that your natural resources are available free means it should be wasted or misused. For example, almost 60% of our fuel reserve, fossil fuel reserves have been consumed in last 200 years in the name of industrial revolution. So what's the problem? Is if the 60% is consumed, if I assume the same rate, less than next 200 years, all the fossil fuel reserves will gone. So the future generation will not live. We have to be very much cautious about the natural resource scarcity, and we have to take care of that. In early 1970s, actually, there was the idea of that resource use and the environmental damage implications assessment. So these were not that time named as LCA or life cycle assessment. Some conscious people or researchers have started thinking it should be done, but there were challenges. As I told you, that a machine you can have, or in a pure mass force relation, Newton's law will be applicable. But whenever it comes related to the living creatures, whether human being or some other, there is no such 1:1 correspondence. Only you have to have the statistical conclusion. And then this has been the starting point of the development of the life cycle assessment methodology. Means people have started thinking, okay, we are consuming resource, we are damaging environment, and we need to go for the renewable energies. how can we make a structured methodology which will be internationally accepted as the methodology to assess that particular damage? And then the concept of LCA or life cycle assessment came. Life cycle assessment is still controversial and still evolving. Don't think that if you do the life cycle assessment, you are getting 100% accurate environmental impact. This is only a standard guideline made for our convenience. And that has to be done because without life cycle assessment, at least the industry and the country data transfer will not be acceptable. But if you just follow the life cycle analysis principle, according to ISO 14000 series, the country to country, they will accept. That's by agreement. But don't think these are the comprehensive, all possible options you have assessed. But we have to do currently without having such alternative option. The goal of LCA is not to arrive at the answer. That means don't think that it's like a question, answer is known. It's only provide a broader strategic planning process. That means on the basis of LCA, if you get a very green signal that it's a red light, you have a serious problem, the LCA give you a indication that that's going to be very much damaging, you should take care of that. So it's only an indicator, not the full answer of the environmental impact. So as a summary, according to ISO, International Standard Organization, LCA is a compilation and evaluation of the inputs, outputs, and potential environmental impacts of a product throughout its life cycle. So now you can be very confident that don't think LCA give you comprehensive environmental analysis, but people have accepted as their convenience, or better to say not the convenience. In absence of all other things, this has to be accepted. And also moreover, continuous improvement of LCA is going on. In fact, my student who is working now in Germany as a postdoc, he is telling they are comparing the different LCA database and comparing as a part of research how they are different. That means what is the life cycle assessment result from different database or inventory that I'm explaining, whether they are converging to the same point or not. If not, then obviously the standard is not giving a unified single solution. Anyway, now what are the stages of life cycle and stages in the life cycle activity? So we have a primary resource, in general, any production process, then extraction and processing. Obviously, we have to do that. If you want to do a steel industry, iron has to be extracted from the ore. Otherwise, you cannot do that. Then there is a production. So only producing steel can be the steel company's objective. And they are selling it in the standard size and dimension, which you call it ingot, to the market. But then subsequently, the steel is being processed for different utility. Some steel may go for railways or making rails. Some steel may go for the utensils, etc., etc. So at each stage, there is a production. And for each production stage, there are certain environmental impact. Let it be. After that, it started getting used. During use also, there may be certain environmental impact. Then a very important question is raised. After the use, is it a waste, or we can make it reuse or recycle? That's the concept of circular economy, given another name. All are converging towards the sustainable development concept. So whether you can make the reuse or recycle that particular generated waste after use, that makes a very big dimension or paradigm shift of a particular product. And in environmental life cycle analysis, does that have a big impact? Then if you cannot do that, it will be a waste, and that you have to make a disposal. And that creates the emissions and waste. So with this particular life cycle chain, if we consider, to make the impact at every stage is the framework of LCA. Sorry. But in LCA analysis, according to 14040 and 14044, we have that particular concept of three important framework. In the framework, there are three important issues. You know that in legal system also, there are different, very beginning, you have got two different sections. One is the civil, another is the criminal. And then criminal laws proceedings are something like, their way of proceedings are also different from the civil proceeding. Similarly, here also it is stated that in life cycle analysis, if you have to do, initially you have to define the goal and scope of your definition. Goal and scope definition, sorry. Why? Say you are having a used utensil and you are disposing of. The question comes, then is it the pollution you only have created? Or that pollution or environmental impact has been started when the original iron ore was extracted from below the ground or mines? Why? Because if you want to assign the particular responsibility of damaging environment, then the consumer should not be only damaged. Should not be affected. Should not be rather assigned. There should be a very good definition or precise definition who early have caused those damages. So, if you want to take the responsibility of each of these steps, you have to define the scope and goal. That means what you want to do. And then once you have done that, you have to go for the inventory analysis. This is the heart of the life cycle assessment, where you have to make these correlations. Say, we have carbon dioxide emission. That carbon dioxide for the human health, a very benign thing. If there is no carbon dioxide, only carbon dioxide, no oxygen, you can get suffocated or rather you can expire. But carbon dioxide itself is not toxic. All of you might be knowing that when the oxygen has to be given to a patient, certain carbon dioxide has to be mixed. Otherwise, there will be some bad effect on the health. So automatically carbon dioxide for the human health, it's not a problem. The main problem of carbon dioxide is going to the atmosphere. They will create that particular, global warming problem. So the inventory analysis means which has got what impact. These correlations are continuously evolving. Some days, maybe some years back during our childhood, we have used benzene vapor to be a standard medicinal effect for whenever we have some small cough and cold problem. I myself was used under the doctor's prescription. But now, this is a declared carcinogenic element. Nobody should use benzene directly as for a medicinal benefit. And interestingly, this is called the inventory. That means how you can make the knowledge inventory to find out the correlations of different damaging things. And this is evolving, and different inventory are getting, we call it inventory database. EcoInvent is one of that, mostly leading by the Netherlands. And now there are the different database inventory in the life cycle analysis are getting developed. And the main heart of this life cycle assessment is this inventory analysis and its enrichment. Now comes the impact assessment, which is the most important part. Once you have following the inventory analysis only, you can do that. Because if there is no interpretation which causes what damage, how can you make that impact? And then you have to make the final interpretation out of all this analysis, what is the life cycle assessment part. Then once you get that, you have to use that result for the strategic planning, public policy, marketing, and other things. Life cycle assessment has been developed for these purposes, not to immediately stop the pollution. Then goal and scope definitions will be something like that. Purpose of the study and its intended use, you have to mention. The system and system boundaries you have to define. For example, if you want to take the responsibility of the steel producer, then you should not assign the full responsibility of the environmental impact on the producer. You have to take the responsibility of the person, or rather share the responsibility of the person who has actually made profit out of the mining ores. So assigning those responsibilities to individually properly is a very important aspect, which is called the system boundaries. Then the functional unit, which actually you are concentrating on to find out that particular thing. In fact, the system boundary defines the input-output relations, and the functional unit is that which actually converts for our utility goods. Then data quality, the assumption and the limitations of this study. Sometimes what it happens, the data is not also very proper. Say you are using a particular alloy in a particular production process. But unfortunately, that alloy percentage of all the elements are not properly known. If known, then also each of the element that makes that particular alloy is also not properly defined or known to you. So you have to assume something alternate, and that's due to the unavailability of data. So your result of LCA will also change. So the data quality and then assumptions for your convenience, whatever you make, and limitations are the basic limitations of this particular life cycle assessment. Then there comes the full LCA study, where the full means we call it cradle to grave. Means when a baby is born, it generally from the mother, when he or she is separated, they are given to a cradle, and then finally after our life is over, we go to the grave, or rather we are cremated. So if you want to take the entire impact of the life cycle, you have to go from cradle to grave analysis. But sometimes it happens that we are not interested with that. We want to get to a partial, say in a production unit, how much damage is being done. Then after the production unit is done, from that, as it goes out of the gate of that particular workshop, the responsibility of transportation environmental impact should not be assigned on them. This is very important, whether you have understood properly within which boundary and with what assumptions you are doing the LCA. Otherwise, the results interpretation will be wrong. One of the most important element of LCA is the functional unit that represents a quantitative measure of the output of products or services. Unless you can properly define which functional unit LCA you want to do, your results interpretation will not be proper. Now, this goal and scope definitions, I think I should not, because I made some more slides in this LCA. I expect that LCA will not that be common like economic analysis for most of the people. But summary, because I have to finish up the things at the end. So if I make a summary, in LCA, it's a very standardized international method for assessment of environmental impact, but that's the accepted principle or regulation globally. That is not to be assumed or rather believed actually that is giving the results. And that's why the inventory database is continuously changing. If you make an analysis on the basis of inventory analysis of today, inventory database of today, whatever the impacts you will get, after 10 years, you will get a different. So it's a definition. Don't accept that it is absolute truth. Then the structure of the LC analysis is something like that. There is the material, energy, water, air, and output also you are getting. One example, say, let's see, whenever you have got a targeted product, which you call principal product, there will be some co-products. One of the big example of that is refinery. In refinery, maybe petrol and diesel are the prime target from the crude oil to get it. But there are some many other products coming out. Those from the chemical engineering background, they know it very well. Almost every fraction of that particular crude oil, this is a fractional distillation process mostly, then out of that, every product is an useful product. So if you want to make an environmental impact or life cycle analysis of that process, who will be assigned to whom? Should the co-products also not take some responsibility? Yes, they are not the waste. If they are waste, then it is different. And if they are not waste, you have to take that responsibility also, because you are producing that and using that, and that process is responsible for that. Then inventory analysis, assignment, mathematical, modeling. I think I should not go into these details because I understand that it's a mixed audience. So if I go into more mathematics, but still I'm showing this because within the the environmental impact or inventory analysis is done. There are certain very defined, well-defined the environmental burden, and then depending on the component or fraction of that particular thing, we can make the overall impact. Then the final impact analysis, we have to do some classification, characterization, and then normalization is very much important, because if you want to make the total impact, then on the basis of the total impact, you have to assign the contribution of each with a normalization principle. And then finally, you can do the valuation. So Sustainable development is a concept difficult to achieve. But if you give some effort, then obviously you will have a better practice of living. Again, it's a better practice of living, not actually, that's the concept why I mentioned achieving God or moving in the path of godliness are completely different. Not completely, it's a part of that, but never be boasting that I have achieved the God. I am following a path that can make me closer to the God. Similarly, the basic idea of that is fulfill your need, not your greed. Now I'm coming to another aspect of multi-criteria decision making. This is very much important mathematical tool. I will not go into the mathematics part because that may be a little bit complex and difficult for many people. But as I've mentioned, the sustainability, overall sustainability is depending on several factors, and never you can make them optimized all together. You have to make a balance of these. And then that's why this mathematical framework of decision making has come into the picture. You have to rank or choose alternatives. Alternatives means, say you have the same action you can take through different 4 paths. You have to choose the better one. Then you have to find out with respect to multiple criteria, and you must have to prioritize them also. Otherwise, you don't get the optimum solution. So the basic principle of MCDM, which is a purely mathematical framework, we can do it through the mathematical structured way. Alternatives you have to decide to that particular formulation. What are alternatives you have? Then which criteria basis you want to define the optimal solution? Because mathematics doesn't know the sustainability concept. It only knows the mathematical path. So you have to define what are the criteria and their numerical values. And then you have to assign the weights. Weights means priority. Whether you are giving the highest priority to the environmental parameters or to the economic parameters, that you have to decide. So accordingly, your solution will emerge. No unique solution will be there for sustainable solutions. So MCDA is about getting these 3 things rightly. That means with right proportion or sharing of the responsibility. So path is something like this: start, then selection of system objectives, determine the different criterion, choosing alternative system to fulfill the objectives, then regulating weight priority, which one you want to give the priority, whether economic priority. For our country, poor country, relatively, we cannot give the highest priority to the environment. We always have to think of making a good priority to the economic solution. So then you have to give that MCDM method. We have a different MCDM method to choose that optimal solution. Now, steps to approach: identify the problem or the issue on which you want to apply the MCDM, then problem structuring, then model development, analysis, and finally, output selection and decided optimal solution. Then MCDM problem has 4 different elements. The goal you have to define, similar to that particular LCA. Then objectives you have to define. The objective means within the goal, what are the criteria you want to define. Then alternatives you have to decide, and based on that, the optimal solution will emerge. The types of MCDM I will not discuss in much of detail because I understand this will be a little bit difficult for all of you. But the only criteria I want to mention, the outranking, distance-based method, these are purely mathematical method. But when you come to the fuzzy-based method, then some degree of uncertainties are also included. Fuzzy, all of you know, doesn't give you any deterministic solution. That's a heuristic solution to some extent. But fuzzy-based mathematical MCDM is also possible. That's also the logic, the flow path of the so-called, which is called the flow chart I have just discussed. But I'm sorry, these are the things that there in my papers. I will refer at the end, and then there you can get all these things in much detail. Now in engineering, what happens? I have an idea, but I have made it. But this is not a direct jump. There are the steps. And in the steps, initially you have to make a modeling, then design, then manufacturing or assembling, then testing, and then finally you can get it. So out of these steps, unfortunately in conventional engineering, we just, whenever we get the best solution, we think if it make a function, and then economic, if it is economic, then engineering is done. But unfortunately, earlier we didn't take care of damaging environment and social inequality. This has to be addressed. And then the concept of sustainable engineering comes into picture. And in fact, in Jadavpur University, a new elective I have offered just from this session, of sustainable engineering, which is beyond the conventional engineering. Only engineering of making physics or rather the scientific basis doesn't solve the problem. They have to take care of the overall sustainability concept of the economics and the environment. So this is a concept path where if you want to become diverging from the sustainability, you can go away. Then it will have a lot of negative effect. But if you want to come closer and closer, I'm not telling you will hit the sustainability at the center, not possible. But sustainability engineering or sustainable engineering teaches you how to make a better path for following the sustainability principle. The basics of sustainable engineering is something like this. Conventional engineering, only the functional performance and economic assessment remain confined within these two. But sustainable engineering means after the conventional engineering is done, then you start making the life cycle assessment to make the environmental impact assessment. Then social sustainability assessment is very much important, which is also tricky. And then economic assessment and go on iterating whether you can get the optimum. And out of that, the final step is to make the multi-criteria optimization decision. And this is the research component where finally for a given particular alternatives, you can reach a closer to sustainable solution. Never claim this is absolute sustainable. But this is the framework we are working for last 10, 15 years continuously. And I will show some of our publications where we have tried to structure those methodology and the framework. A few case studies. Now our result. Interestingly, with my PhD students, I'm working in this area of different sustainable solutions all over India. And in India itself has a very widely demographic and geographic structure. All the solutions may not be acceptable for all the locations. The northeast Arunachal may not have a similar problem or solution like the southern part near Chennai or the desert area in the western part of Rajasthan. So our studies are going on over different locations with different priorities, and that we believe is a sustainable solution. Now, the first paper which we published, or rather I referred to do, is way back 2020. There we have tried to make an optimum combinations of the renewable resources to meet the local power demand in distributed generation. That's the subject topic. Now, that's the Arunachal Pradesh, and this is the geographical, Google map, and this is the location. In fact, in our paper, the reviewer asks for this picture for that location. And this is the situation of that particular village where we are trying to find the sustainable solution. Don't tell them the story of the grid power. They don't know it. So we have to make a better sustainable solution for them, power supply. They now depend on the only diesel-based power for a shorter period of the whole day. Anyway, so what we have done, quickly have to move. We have made a local demand evaluation, the local resource evaluation. Resource is mostly the renewable resources. Then selection of suitable matching between these, which combinations of the hybrid renewable resources can meet that demand. Then single renewable solutions, we have initially started to make that matching because makes the life more simple. But this is not possible. And the combinations of renewable resources were then checked. And interestingly, some occasional DG support, diesel generator support we have recommended. Initially, we are very much suspicious whether that the reviewer will accept or not, because generally any fossil fuel based systems is considered to be unsustainable. But our reason or point was to make that particular power supply sustainable, we have to compromise a little bit DG support, otherwise uninterrupted power will not be there. Then we make a TOPSIS based multi-criteria decision making, and in our way, as we have believed, that's the sustainable solution for that location. Don't try to avoid complete fossil fuel regime. It will be there because there is not alternative options for them. Anyway, so ultimately this looks like DG support, hydro module and the wind module, these three. And interestingly, solar has failed to maintain the sustainability because not of solar radiation is there. So don't think that any solution will always be suitable for all locations. Anyway, so I'm not going into those details. The paper is referred, so you can find it from my Google Scholar site also. You can find those papers. This is the logic we have made. I'm not going to explain, but this is not so simple. We have to make that justify that sustainable solution through different iterative process. And finally, we have found out that this is the combinations of different sources, and the cost may not be always in ratio of the total production of the power. That means that particular renewable resource which will provide the maximum power may not necessarily be the most costly item. So this 1:1 relation is a vague concept. Sorry. Then in our next paper, we have just tried to make some investment risk That's very important point from the sustainability. Because in new technology, generally the investment people do not like to invest in a new technology. So the new technology doesn't get support. This is undoubtedly a social sustainability issue. Unless the bank comes up with loan, then that new technology may not reach to the society. So this paper addressed that particular issue. And interestingly, we have just got that in that analysis also, the Monte Carlo uncertainty analysis has taken care of that particular risk issue. And I'm not going to those details because I'm just showing you the slides to some extent that combining life cycle analysis, techno-economic, and the uncertainty part, we have reached to that particular solution, which is completely described in my published paper. Then there is an issue of polygeneration. Polygeneration means multiple output with some multiple inputs. This is undoubtedly a very important sustainable solutions. We made a review paper also because we consider this polygeneration as a future sustainable energy solution, and undoubtedly this is becoming important in future engineering systems. Then desalination process including the renewable energy is that particular objective of this particular study. So desalination is required in the coastal area. That is required very much because without the water, potable water, you cannot do anything. Now the location is also different. It's not the Arunachal, it's the near to Chennai, and there is no potable water available. So we have just started to making the comparing different desalination process, and finally a polygeneration system has been recommended with best possible sustainability. And then obviously this follows the similar method, but not exactly the same method in assessment of sustainability. Then there also the solution that came. And then in one of the international collaborations, Europe, the most important problem is they use biogas. And in biogas, interestingly, their sustainability assessment, it's a polygeneration system, but their assessment is a different sort of assessment. And interestingly, being a polygeneration researcher, I was included in that team and I contributed to that direction only, and rest of them they have taken care of. And then the machine learning based load forecasting methods, the AI based tools are very powerful if you can use them very properly. And we have found out that the load forecasting is an important factor for the sustainability. And then the initial module is for load forecasting, and then subsequently we have got the next analysis. These pictures I'm showing not to explain, but to show you it's not very easy to conclude, but you have to go through this rigorous mathematical structure to find out those sustainable solutions. Then we have got that multi-criteria decision making for the techno-economic and environmentally sustainable decentralized hybrid power and green hydrogen solution. This is for a particular locations of our Sundarbans, which is a remote place. If we can make the hydrogen as the energy storage, then it's possible. Then we have got that, finally, we have made some, this is another publications actually. Here the sustainability assessment was done on a different principle. We have tried to find out the strength, weakness, opportunity, and threat, the SWOT analysis. We do it in real business management principles. And we have applied the same principle to make the assessment of a particular sustainable solution assessment. And interestingly, there also the principle is a little bit different, but that also gives a pathway to reach a closer to sustainable solution. And that's why these are the 4 factors. It's not readable. I know that's in the paper, you can read all these things. But interestingly, what I want to make you the message that never think that sustainable solutions analysis is going in one way only. You can choose and find out innovative way of sustainable solutions. And the last is the review of multi-criteria decision making for sustainable decentralized hybrid energy systems. Last year only we have published. It's a good review, we believe, that because it provides the international current knowledge status for this sustainability assessment framework for the distributed hybrid energy system. And there you find out several criteria. Not only the 3, and interestingly, sub criteria like risk, whether you want to put it social or you put it into environment or put it into economic, that can become encompassing. So new criteria will come up. These 3 criteria, in my belief, out of my research, is not only fixed, they will remain. They will come in something new. And this is how we just made the methodology of this particular analysis. In the paper, it's there in detail. Now, finally, sustainable development has many directions, but this is not the proper path of becoming divergent. You have to converge them somehow. That should be your target in the research of sustainability methodology. Then conclusion, I don't want to make any conclusion. Leave it to you. If you have any queries, I can discuss. And these are the main two people who have contributed to these results. My Sharon is now not my student now. He is now is a sustainability assessment group of University of Karlsruhe. And then Rishabh is still working with me. So I hope that this is a good forum to discuss, and then in future we can have some collaborative research also. Thank you. I have finished. Now, if you have any queries.
Thank you so much, sir. Participants, if you have any query, then you can ask, please.
I think I have finished within time, no? Okay.
Yes, sir. Any question, please?
Okay, if there is no queries, then I can leave, no?
Yes, sir. Thank you so much, sir. Your lecture was very insightful. Thank you so much,
Thank you.
sir.
Thank you. And anybody is open to have any communication with me, because my communication details are there with the organizers. So if you want to have any subsequent communications for research collaborations and other things, very much welcome. Okay. Thank you.
Okay.
Good night.
Thank you so much, sir. Good night.
Okay.